So now that we know some definitions, let's look at some designs. Common early phase designs include the 3+3, the accelerated titration, and the adaptive models. The 3+3 is shown here with the time periods along the x-axis and the dose generically represented along the y-axis as dose 1, 2, 3, 4, 5, or 6. This does not mean to imply that 2 is double 1 and 3 is 1.5 times 2. This is just varying dose levels. It could be jumping by several hundred milligrams at a time. So the basic concept here with the 3+3 is dose escalation. So we keep escalating until 2/3 have a poor or toxic outcome. So you can see at the bottom of time period 1, dose 1, all 3 participants had a okay or good outcome. So they escalated the dose and tried it out in 3 more participants. All 3 of those participants had a good or solid outcome. So they escalated the dose. The first participant had a good outcome, the second participant did not, and the third participant did. So we escalated again to the 3rd dose level, where the first participant has a good outcome, the second participant has a poor outcome, and the third participant has a good outcome. So we cannot escalate the dose here because we didn't have 3 good outcomes. What we'll do is add 3 more people at this dose level. All 3 of those then have a good outcome. So you can see this is where the 3+3 came in. So at dose level 3, we've now had 5 good outcomes and 1 poor outcome. So we're going to pass it up to dose level 4. Again, 3 good outcomes. Pass it up to dose level 5. Similar situation as dose level 3. The first person had a good outcome. The second person had a bad outcome. The third person had a good outcome. We add 3 more people, 3+3, and we see 3 more good outcomes. So we now go up to dose level 6, where our first person has a good outcome and 2 people have poor outcomes, and so we are done. At dose level 6, we observe 2/3 of people with a poor or toxic outcome. We will not add 3 more people. We will simply back up to dose level 5. So in this situation, if we go back to our definitions, MAD, maximum administered dose, and I told you it was highly similar to the maximum tolerated dose. So MAD is United States, MTD is European Union, but they basically mean the same thing. Maximum tolerated dose means what was the most tolerated dose, and maximum administered dose means what was the highest administered dose. In a number of situations, those may be the same outcome. The maximum tolerated may be also the maximum administered. In the 3+3, because we are waiting for failure, the maximum administered will always be higher than the maximum tolerated, unless, of course, you reach the highest possible dose, and then they would be the same. So in this situation, what would be our maximum administered dose? Would it be dose 4, dose 5, dose 6? And what was the maximum tolerated dose? Again, would it be 4, 5, or 6? Make sure to answer that on your worksheet. In the US, differentiating the MAD, which is the maximum administered dose, we're looking at the maximum tolerated dose. So what would that be by United States standards? Also in the United States and the European Union, they'll refer to the recommended phase 2 dose. What would be the recommended phase 2 dose based on this graph? And how many time periods were studied? And how many time periods did it take? So if you take a look at the time periods, we had 1 time period with success, 2 time periods with success. Our 3rd and 4th time periods were eaten up at the same dose. Our 5th time period was successful. Our 6th and 7th time periods were eaten up with the same dose. And our 8th time period was our final time period. So how many time periods did it take to reach the MAD, and how many did it take to reach the MTD? So that's the 3+3. Fairly straightforward, pretty simple to carry out, and the rules are very clear.